NASA's Pilgrim 1 Space Mechanical Assembly, the farthest journeying space mechanical assembly at any point shipped off, has stunned us. Journeying through the universe for right around 50 years, Adventurer 1 has been sending back critical information from the farthest reaches of the universe, generally driving our perception of the universe. However, continuous transmissions from this amazing transport have presented surprising signs that have left the entire space community in a state of wonder and bewilderment. These signs have sparked debates about whether they are the result of a technical mistake or, on the other hand, if they could indicate something evidently more remarkable, for instance, extraterrestrial activity. Join us as we dive further into the mysteries surrounding these superb transmissions and uncover what might be hiding in the depths of space. Mankind's interest in the mysteries beyond our planet has been a primary motivator for space exploration since its inception. This ravenous curiosity led to the remarkable launch of missions like Pilgrim 1 and Explorer 2, which were among the most aggressive space endeavors of their time. The launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977, marked the beginning of a new era in space exploration. Just a brief time after, on September 5, Explorer 1 followed, clearing the path for an extraordinary journey. These twin transports, each weighing around 720 kilograms, roughly equivalent to a small car, were launched during a strategic arrangement of the outer planets, which played a critical role in their orbits and mission results. Throughout their striking odyssey, these space probes traveled in various directions and at different speeds. A pivotal moment occurred on December 15, 1977, when Explorer 1 overtook its twin due to differences in their trajectories. Since then, Explorer 1 has emerged as a fundamental asset, providing critical information that has transformed our understanding of the universe and its many phenomena. Before we dive into Explorer 1's most recent bewildering discovery, which has captured the attention of the entire space community, let's review some of its most notable achievements. In 1978, during its Jovian imaging mission, Explorer 1 was positioned around 265 million kilometers from Earth. By January 1979, it had embarked on a remarkable 100-hour mission, capturing a time-lapse film of Jupiter's rotation. This series of 3,750 images provided exceptional views of Jupiter's dynamic atmosphere and its complex features. The spacecraft's discoveries included the detection of a small ring around Jupiter and 2 previously unknown moons, greatly expanding our understanding of the gas giant's intricate system. To ensure the spacecraft's safe entry and avoid potential collisions with Titan, one of Saturn's moons, corrective maneuvers were performed after the successful Saturn mission. Experts decided to end the planetary mission of both Explorer 1 and Explorer 2. However, the spacecraft were redirected on a new course beyond the limits of our solar system, traveling at an astonishing rate of 325 million kilometers each year. In January 1990, the interstellar mission began, with Explorer 1 continuing its celestial journey. During this period, Explorer 1 made significant discoveries, including the identification of 4 additional moons, Mimas, Enceladus, Tethys, and Rhea. It also captured some of the most famous images ever taken of our solar system. On February 14, 1990, Explorer 1, at a distance of approximately 6 billion kilometers from the Sun, embarked on a visual venture known as the Family Portrait, capturing stunning images of the inner planets. This collection of 60 images contributed to Explorer 1's remarkable catalog of 670 photos taken during its encounter with Neptune. Explorer 2 also achieved remarkable accomplishments during its mission, recording wind speeds exceeding 13,100 meters per second, the fastest winds ever observed in our solar system. This achievement provided crucial insights into Neptune's distant atmosphere and its largest moon, Triton, whose surface temperature drops to a frigid -391 degrees Fahrenheit, making it one of the coldest places in our solar system. Triton also displayed unique features, including ice volcanoes that ejected nitrogen gas and hurled frozen particles 5 kilometers into its overcast atmosphere. These extraordinary discoveries have expanded our understanding of the varied and complex nature of celestial bodies in the outer reaches of our solar system. The Explorer missions have provided crucial and groundbreaking results. Explorer 1 and Explorer 2 revealed that Jupiter and Saturn's moons, once believed to be heavily scarred and dormant, are in fact undergoing geological activity. Explorer 2, in particular, achieved several historic milestones, including being the first spacecraft to fly by Uranus and Neptune and remains the only spacecraft to have done so. NASA employed various strategies to extend the operational lifespan of these ambitious spacecraft, including shutting down unnecessary radiators and systems to conserve energy. The mission is expected to conclude in 2030, marking a moment of pride and a touch of sorrow for the scientists and engineers who have dedicated themselves to this extraordinary endeavor. The design of Explorer 1 and Explorer 2 was a marvel of engineering. These spacecraft were designed as stable platforms, rotating at a rate more than 100 times slower than the ticking of a clock's hour hand. This design decision reduced visual blurring as the probes crossed the vast expanse of space. Even before reaching the outer planets, the probes began sending pictures of Jupiter, revealing its swirling clouds and iconic features like the Great Red Spot, a massive storm on Jupiter that captivated audiences at NASA's Jet Propulsion Laboratory. However, the discovery of active volcanoes on Jupiter's moon Io garnered the most attention. The spacecraft's instruments detected anomalous signals from Io, which were confirmed by remarkable images showing towering volcanic plumes and a surface scarred by eruptions. One of Io's most prominent volcanoes erupted with a force 1,000 times greater than that of Mount St. Helens, covering an area nearly the size of France. As the spacecraft continued their journey, their cameras were eventually turned off to conserve power and memory before they ventured into interstellar space. Remarkably, the photos they caught did exclude Mercury or Mars because of different variables past the Explorer tests. NASA has sent off other eminent rockets including Trailblazer 10, Trailblazer 11, and New Skylines on February 17, 1998. Trailblazer 10 outperformed Trailblazer 11, becoming the space apparatus farthest from Earth. Notwithstanding the shortfall of other space tests to notice it, Explorer 1 proceeded on its lone excursion for 14 additional years before entering interstellar space on August 25, 2012. The advancement of the Explorer missions was made conceivable through different imaginative strategies, with gravity assist moves standing apart as particularly brilliant. These moves were critical for driving the spacecraft to their far-off objections and gathering important information. The spacecraft depended not just on their own drive systems, but also on gravity assists to accomplish their objectives. Envision 2 fearless spacecraft deftly exploring through our nearby planetary system, utilizing the gravitational draw of planets to impel themselves forward. This divine dance permitted them to save fuel and accomplish the important speeds to visit different areas. Gravity assist moves involve giving the rocket the small amount of a planet's energy as it passes by with extreme accuracy. For instance, as Explorer 1 moved toward Jupiter, the planet's huge gravitational attraction sped up the spacecraft's speed. Achieving such accuracy was critical. Any deviation from the right point or speed could have brought about a disastrous result. Regardless of the overwhelming accuracy required, the splendid personalities behind these missions successfully executed these gravity assists multiple times, sending the shuttle on a surprising venture. The amazing excursion, made conceivable by these heavenly moves, saw Explorer 2 utilizing gravity assist from Jupiter and Saturn to reach Uranus and Neptune. The progress of the Explorer missions owes a lot to these gravity assists. As we think about the exceptional excursion of these exploratory shuttles and the abundance of data they have provided, we anxiously anticipate further updates on the examination concerning Explorer 1's new abnormalities. Both Voyager 1 and Voyager 2 continue their missions past regular limits, and their accomplishments include Jupiter and its moons, Saturn and its moons, Uranus and Neptune. Voyager 1's time-lapse pictures showcase 10 rotations of Jupiter in striking detail, including the discovery of new moons and a little ring. These revelations have incredibly enhanced our understanding of Jupiter's complex system. Voyager 1 also tracked down 4 extra moons of Saturn, Mimas, Enceladus, Tethys, and Rhea, and took amazing photographs of Saturn and its rings, offering new insights into Saturn's complex system. The spacecraft left a mark on the world by visiting Uranus and Neptune, providing important information about their atmospheres and moons, and improving our understanding of the outer regions of our solar system. Later, finishing their planetary missions, Voyager 1 and Voyager 2 ventured into interstellar space, gathering information on the immense environment. This ongoing examination continues to expand our knowledge of the universe beyond our solar system. As we expect more data about Voyager 1's most recent signals and their potential implications for how we might interpret the universe, the wonderful journey of the spacecraft remains a wellspring of inspiration and interest for scientists and space enthusiasts alike. Their notable achievements continue to push the boundaries of human knowledge and exploration, highlighting the boundless potential of space discovery. The Voyager missions have provided us with a goldmine of data about our solar system and beyond. The famous pictures and information the spacecraft have also delivered a brilliant record, a unique relic intended to share the story of our world with extraterrestrials. This record contains sounds and images chosen to represent the diversity of life and culture on Earth. It includes greetings in 55 languages, music from various cultures, and a selection of natural sounds, such as thunder and whale song. This message in a bottle, so to speak, reflects the hope that one day, if intelligent life exists elsewhere, they may find and understand it, offering a glimpse into humankind's essence. Voyager 1 and Voyager 2 were equipped with scientific instruments that have changed our understanding. These instruments included magnetometers, plasma wave detectors, cosmic ray instruments, and imaging systems, each contributing essential data about space phenomena. For instance, the magnetometers have provided insights into the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, revealing the complex interactions between these planets and their surroundings. The plasma wave detectors helped us understand the nature of the solar wind and its interaction with planetary atmospheres. Furthermore, magnetospheres, one of the most striking aspects of the Voyager missions, is their ability to measure the heliosphere boundary, a vast bubble of solar particles and magnetic fields that surrounds our solar system. As Voyager 1 approached the edge of this boundary, it detected the sudden transition from the solar wind to the interstellar medium. This data has been instrumental in shaping our understanding of the heliosphere structure and its role in shielding Earth from cosmic radiation. The spacecraft's observations have provided evidence of a distinct boundary where the solar wind slows down and becomes denser, known as the termination shock. Beyond this point lies the heliosheath, a region where the solar wind interacts with the interstellar medium, creating a complex and dynamic environment. Voyager 2's journey has been similarly crucial. After its successful flybys of Jupiter, Saturn, Uranus, and Neptune, it has continued to provide significant information on the outer reaches of our solar system. Voyager 2's observations of Uranus were particularly striking, revealing an exceptional magnetic field that is significantly tilted compared to the planet's rotational axis. This discovery challenged existing models of planetary magnetism and spurred further investigation into the magnetic properties of other celestial bodies. In addition to their scientific contributions, the Voyager missions have had a profound impact on public interest in space exploration. The stunning images of distant planets and their moons, coupled with the personal stories of the spacecraft's journeys, have captured the imagination of people around the world. The photos of Saturn's rings and the detailed views of Jupiter's moons, especially Io's volcanic activity, have inspired countless individuals and have been featured in educational materials, documentaries, and popular media.